So this is my little side project I've been working on for a while. The idea is simply to learn foreign languages by translation, in particular Italian. So let me just show the demo quickly, and then how it works. Okay. So the idea here is you just have a sentence, and you have to, it's in English, and you have to translate it into Italian. So for example, this would be something like, let me guess. Corto sognato. Okay, so I got it right, and it's green as a result. So if you do it wrong, it will show you underlined in red the parts you got wrong. And it's kind of amusing, the sentences that it comes up with. So there's just these really random sentences, and they're generated by grammar. So most of my little 5-minute talk is just about how these sentences are come about. So with that being the demo, let me go into some more about how it works. If I can find this. Yeah. So natural language sentence generation. I suppose most people are probably familiar with grammars, context-free grammars. You basically have a set of rules, and the rules define what strings can be generated in the language. So here's an example with 3 rules: sentence, verb phrase, and noun phrase, and it generates the sentence: the woman sees the cat. So that's a good model for language generation, natural language generation. That's what I use, and you can use it for computer programming languages, whatever. But of course, natural language is a lot more complex than computer languages. So the simple rule-based approach has some problems. So, for example, agreement in Italian, which is the language I was concerned about learning, or I'm trying to learn a little bit. My wife and I are trying to. There's agreement between nouns and articles. So, la donna, the woman, is okay. Same as in English, the woman. But you can't say il donna, because il is the masculine article. So how can you handle this with context-free grammars? You could have 2 different rules, where you have a feminine noun phrase goes to a feminine determiner, like la, and a feminine noun, like donna, and then you have a masculine noun phrase, which goes to masculine determiner and masculine noun. So the problem is, though, that you end up with all these rules that don't really capture the generality, which is that there's an agreement between the noun and the article. And rather than doing that, rather than having separate rules, maybe we can combine these into a single rule. So this is the general approach is called unification grammars. And the idea is that there's it's not simply a tree, but rather it's a DAG, a directed acyclic graph. And information is shared between the nodes of the tree. So for example, here, the noun phrase, rather than having 2 separate rules for masculine and feminine, you have 1 rule, and they share the information about the gender. So they share whether it's masculine or feminine. So sentence generation in this approach becomes general grammar rules that encode structure sharing relationships, a lexicon which has these has information about agreement, number, gender, these type of things, and unification, which is the process of taking lexical entries and combining them into grammar rules to make sentences, to make larger constituents. So that's the general idea. So I use Clojure. Clojure is the language I wrote it in. It's a dialect of Lisp that runs on the JVM. And it supports a couple of things which allows me to do this. It supports maps, which are a set of key value pairs, and references, which are ways of encoding structure sharing. So it allows you to not just have trees, but also have directed acyclic graphs. So it allows you to have nodes that, or arcs that point to the same node. More than one arc can point to one node. Let me show a quick demo of that. Sorry. Okay, so here's an example of a map. Okay. So basically, I wrote a little web app using Clojure's web app functionality. It builds on top of Java. So it allows you to type in an S expression and see the result, sort of like Mathematica, kind of like that. So I'm curious if maybe other people can let me know if there's other Common Lisp or Java or Clojure environments that let you kind of. I think it's interesting to not just use a REPL, but also to use a kind of a web interface to do programming, to do this kind of interactive evaluation. So NREPL. Well, I use NREPL with Lisp, which I do that a lot.
This is a Clojure.
Yeah. But does it have a web interface also, or yeah? But
light table should be.
Oh, light table, yeah. I haven't looked at light table, but I really want to. Yeah. Oh, yeah. Cool. Yeah. So here's an example of using a ref. So basically, this constructs a reference, and it's going to. Okay, so this means that this is not just a map. It's different than saying, for example, these values are not shared, whereas the values down here are shared. So if we set the reference to be of the value, say 42, these are actually the same value, and if we if we do unify with another map where A is say 43, yeah, let's take this example. So top means like the most general value. Anything can unify with top. So for example, 43 can unify with top, 42 can unify whatever. So we can say, if we do like this, these are the same. So both A and B are set to 43. So that's basically the idea of unification.
This is Clojure's one shadowy reference.
Yeah, right. Yeah, it's a Lisp one in that like symbols and functions are in the same namespace, right?
Yes.
Yeah. So Clojure is a Lisp one, so that shows that characteristic of Clojure. So I don't want to run out of time. Let me just continue quickly with a very short demo, and I'm just going to show the sentences, show NREPL, as Bob talked about. So this is a function that returns this complicated thing, which is basically a sentence, and it's impossible to read. So here's something called FO, which means just format. It just takes a sentence and takes all this grammatical information and just turns it into a string. And so you can just generate sentences to your heart's delight. And over here in the log, you can see the sentences being generated. And I apologize, the screen is smaller than the amount of information I'd like to show. But basically, it's just going to generate sentences according to the grammatical rules, and it's going to do unification and making sure that all the agreement checks out and everything makes sense as a sentence. So that's basically it. Like I just want to go through some future. Just one more thing to say about that. Like you can also, I've made it so that you can add specifications for the sentence. So you can say that I only want to generate sentences that talk about dormire, which means to sleep, or I only want noun phrases that are about Donna, which is a woman. So I only want sentences about a woman. So you can have sentences that are tailored to a particular purpose. If you're doing language learning, you might want to say, I want to do irregular verbs. I want to do verbs, past verbs. I want to do. Italian has a lot of tenses, and so it's difficult. That's one of the difficult things to learn about it. So the idea is that you could write a customized language learning app that matches your abilities, that tests your weaknesses, that concentrates on the things that you want to learn, you need to know. And this kind of core functionality of generation allows you to focus the generation according to the criteria that you want to test for. So lazy sequences are really useful. Use those a lot. I use MongoDB, serialized and deserialized. So the idea here is that MongoDB is storing a text representation of these DAGs, and it doesn't store the reentrances. The fact that there's structure sharing is only in the data structure in memory. It's not on the disk. So you have to serialize and deserialize the data. You have to take something that's a flat structure and turn it into a data structure. So on disk into a data structure in memory that's shared. So that was that's an interesting thing that I worked on. This is the source code demo site. Head-driven phrase structure grammar is the linguistic theory that I used for this. So it's been around a long time. It's been around like 15 years, 20 years, and people. It's very active community in Stanford, I think, that are still working on it. That the interactive development environment, which I showed you here, that's using Clojure by Anthony Grimes, really smart young man. So it's a way of putting a REPL in a web interface in a safe way. So you can blacklist namespaces. You can only let users do certain things. It's a great way to learn Clojure. There's a site called Clojure that lets you type in X expressions, and it gives you feedback if you got it right or not. It evaluates it for you, but it's also very safe. It allows you to expose a REPL in a way that's safe. Congo Mongo is Sean Corfield. He does the meetups. He's very active in the Clojure SF meetup, and I think I've seen some of you there, I'm sure. He's a really great guy, so I'm very grateful to him for Congo Mongo, so support for Mongo and Clojure. So that's it. Thank you. Oh yeah.
I wanted to mention that Balisp is a common list to web, and years ago for scientific applications.
Oh, Biobank.
It's an representation system.
Yeah, thank you.
Do you think working on this, not doing the exercise, but actually solving problems writing the code helped you learn Italian?
No, yeah, I get kind of in these rabbit holes, and I just go down into very general questions that don't have anything to do with Italian. But I feel like I'm finally getting above water, where I can start getting back into learning Italian. So I feel like I've come a long way. Now it's time to get back into the actual linguistics and learning Italian.
How close do you have to be when you type in the translation?
Well, that's a good point. Like, there's more than one way to translate a sentence that could be right, and right now it only accepts one possibility, and it uses a Levenstein just string distance. So you got this word right, you got this word wrong, and you missed this, you missed these letters.
Kind of one-to-one.
Yeah, it's got to be one-to-one.
Right.
But it would be interesting. I think one thing, because the formalism that I'm using at GPSG allows for a uniform representation of syntax and semantics. It's all these maps, these DAGs. So you could say, well, it ends up with the same semantics, even though you translated it in a totally different way. The semantics is the same, so therefore you're right. And so that's what I would like to eventually do.
Okay.
Yeah.
So the English version of those sentences had slightly awkward phrasing.
Yeah.
And so how have you been able to validate that the Italian version is actually sensible?
Yeah, I need an Italian native speaker to help me because it's probably they would find a lot of bugs in this. So I very much like to have an Italian linguist or just an average person tell me why these sentences are wrong, why these translations are wrong.
Well, I would say this makes sense because taking it up to the next level is a lot more difficult. Yeah. So, bad English to bad Italian, you are learning Italian.
Yeah, yeah.
And then when you're exposed to decent Italian,
Yeah.
it's just a small
Right.
delta.
Yeah.
But, I'm sure as the engineers at Google can tell you, natural language processing is not an easy problem.
Right, yeah. Yeah, another approach I would like to think about, like I'm writing the grammars by hand. I would like to kind of maybe induce them from examples from statistical analysis. Speaking of Google, I mean I know they do their natural language translation based on statistical analysis of bilinear text, I believe.
Yeah.
So it would be really cool to try to, rather than hand coding a grammar with all the brittleness and fragility and labor that goes into that, it would be nice to be able to just induce it from corpus. And this formalism I think is really amenable to that. It's really, it can go either way. You can generate, you can also parse. And the way parsing would work is you would try to generate an analysis using the grammar of the sentence, and you would say, well, I can parse this much of it according to my grammar, but I couldn't parse it all, and you could refine the grammar based on that, either by hand or by maybe some kind of machine learning, hill climbing, simulated annealing or something like that. But it's really a declarative form. The grammar is these rules are declarative. They don't specify whether you're generating or parsing. They're very declarative, so they're good for either direction.
It seems like this approach might be quite applicable to working with constrained natural languages, where the rules tend to be a little simpler.
Yeah.
And in particular, for generation of, let's say you have some information, you want to express it in something that looks like English. You don't have to have the complete generality of the English language.
Right.
Something that's constrained in that.
Yeah.
I forget his name offhand, but the guy that does the Attempto language.
Yeah, this is about it too. Yeah, it's Attempto comment.
Attempto?
Yeah, it's like a restricted natural language.
And he did a survey of constrained natural languages paper, which is kind of interesting because you can look and see, how they differ and what parts of English they try and handle and what parts of English they don't.
There's this book.
Yeah, that reminds me of in Wikipedia there's English and there's also simplified English. So it would be interesting to look at that as a sub-dialect of English.
Yeah, there's several dozen languages that we will come up with for various purposes.
Yeah. Thank you, sir.